again, let's just continue solving rational equations. So the first step is to get a least common denominator, and you have to factor the denominators first in order to do that. These denominators don't need to be factored. They are the binomial t minus 2 and the binomial t plus 4. So the LCD for this problem is that t minus 2 and that t plus 4. Now, could I get you to visualize, first, a couple of things. Do you see the proportion here? So when you have a fraction equal to a fraction, don't forget that you're allowed to set this product right here. I'm going to go ahead and write it down. So you're allowed to set the cross products, t plus 5 times t plus 4, equal to one another. So t minus 2 times t minus 2. I'm rid of the denominators. They're gone. However, you could have thought of this in this way. So after the fact, remember that the LCD is the t minus 2 and the t plus 4. So I could multiply both sides of this equation by that t minus 2 and that t plus 4. And remember, I already had that denominator, so those are going to be removed because they're equal to 1. And the t plus 5 is going to get multiplied by the t plus 4. Just recognize that that's a binomial. So there we are. And I already had that denominator, so I knew that t minus 2 was the missing piece. And so this t minus 2 was going to get multiplied by the t minus 2. Now, when you're in this situation and you got to solve it, well, you better just FOIL these. So you better just multiply them out. And I'm not going to show the outside and inside step. I'm just going to say to you that t times t is t squared. Right here, right there, you have 4t. And right here, you have 5t. Those are like terms. They total to 9t. You need to be able to do that as you move on through your algebra sequence. And then 5 times 4 is 20. So that foils into this trinomial. So same thing over here. T times t is that t squared. And then this minus 2t and this minus 2t is a total of a minus 4t. They are like terms. And this minus times this minus is a positive 4. So you step back and you look at this and you go, geez, I got t squareds. You know, how do I solve this? I wonder if I'm going to have to use the zero product rule and solve it by factoring because I have those t squared terms. Well, if so, I better get 0 on one side. But when I subtract t squared from both sides of that statement, the t squareds disappear. So no, I don't have a quadratic. I don't have a situation that I have to solve by factoring. I have a linear equation to solve. And I just have to get the t's together on one side. So I'm going to add 4t to both sides. And if you don't mind, at the same time, I'm going to subtract 20 from both sides. And I'm going to take this up over here. So 9t plus 4t is 13t. And then 4 minus 20 is a negative 16. And then when I divide both sides by 13, I get a solution of a negative 16 over 13. My restrictions for this problem, look at the original problem. T minus 2 was in this denominator, so I know that t could not equal the number 2. And t plus 4 was in that denominator, so I know that t cannot equal a negative 4. My value for t did not turn out to be that, so I know it's not one of the restrictions. Again, I should check it, but at this point I'm kind of out of space, and I will go back and check a few of these. Matter of fact, you know, boy, the next one I won't have a lot of space either. Tell you what, let's do this one. So we're going to have to write the original problem, so let's just keep our answer down. Put the original problem back up here so that we can do the checking. And the reason I want to do it is many of us don't like to check with fractions. So the problem was t plus 5 over t minus 2, and then t minus 2 over t plus 4. So everywhere I see t, I need to put in a negative 16 over 13. So right there, a negative 16 over 13 plus 5. I'm going to write that as 5 over 1 so that I can get ready to add those fractions. And right here, a negative 16 over 13 minus 2, and I'm going to write that as 2 over 1. Let's go ahead, I guess, and let's write here a negative 16 over 13 minus the 2 over 1, and a negative 16 over 13 plus the 4. So all these got to have common denominators of 13 in order to add or subtract those fractions. So this one's got to be multiplied by 13 over 13. So let's see, 5 times 13, 15, carry the 1, 65. So let's go ahead. We've got a negative 16/13 plus 65 over 13. Trying to decide where I'm going to put all this. Let's go ahead and just do the left side of this, and then let's put multiply this by 13 over 13. So in that denominator we have a negative 16 over 13 minus 26 over 13. Let's just finish this right here. So upstairs a negative 16 plus 65 is 49 over 13. And then down here, a negative 16 minus 26 is a negative 42 over 13. And when I divide with fractions, I have to multiply by the reciprocal. So I'm going to take 49/13 and I'm going to multiply by a negative, I'm going to stick the fraction out here, 13 over 42. So I just flipped that. And these are going to be removed. And so the numerator of this problem is equal to a negative 49 over 42, and I should probably reduce that. 7 goes into each of those, so a negative 7 over 6. Yikes, this is a lot of work. I think I'm going to erase all of that and see if when I put the 16, so it's right here, I'm going to work with this piece right now, see if when I subtract and or add those, see if I get a negative 7/6. So would you kind of just keep that note? And I'm going to erase all of this. I might just stick that value up here. Negative 7/6 is what I'm hoping for. So right here, I'm going to multiply this by 13 over 13, and this by 13 over 13. So I've got a negative 16/13 minus 26/13. And downstairs, I have a negative 16/13 plus 4 times 13, 12, carry the 1, 52/13. And so up here again, I've got that negative 42 over 13. And down here, I've got negative 16 plus 52. So that's going to be 36 over 13. I just got to pause because I didn't bother to do this before we started. All right, and then I'm going to multiply by the reciprocal, so I've got a negative 42/13, and I'm going to multiply by 13 over 36, and these are going to reduce, and so my results for the right side of this fraction is a negative 42 over 36. I believe 6 goes into each of those, 7 times upstairs and 6 times downstairs, and whew, that's a lot of work. You can do it with your calculator. I'm not an advocate of doing that with my calculator, but that's what I should be doing every time, is checking all these problems. I'm not going to be able to keep doing that on the video clips. I want to show you how to solve the problems, but I should always be putting in my answer into the original equation to see if I get the same results. Does the left side equal the right side? We better stop, give you a break, and do another.